Okay, this lesson is about atmospheric processes, and our goal is to understand these processes that happen in our atmosphere. So, by the end of the lesson, I want you to explain what they are and how they impact the atmosphere. The main source of energy in our atmosphere is obviously from the sun, and we get this energy from short-wave solar radiation. That's really important to know because that's why the ozone is so important. It filters all the harmful radiation from these short waves. The amount of energy that we get on the planet is determined by three factors. Basically, the distance from the sun. Our orbit around the sun isn't a perfect circle, so sometimes we can be closer to the sun and sometimes further away. Obviously, the closer you are to the sun, the hotter the temperatures will get because we get more sun. And then latitude, that means the distance from the equator. Obviously, the poles receive half the amount of solar radiation than at the equator. And then we've got seasons as well, the length of day and night. Remember, in the southern hemisphere, we're at the opposite of seasons in the northern hemisphere. Why do we get seasons? Well, it's the Earth's tilt towards the sun. The closer we are to the sun means the hotter season, so the spring and the summer, and the opposite when we go to winter. Remember, not all solar radiation hits the Earth's surface, and that's why the ozone is such an amazing thing, because it filters out all those harmful UV radiation waves. It also gets reflected from clouds, from the surface, from dust in the atmosphere. It does get absorbed and it gets scattered. The ratio between incoming and outgoing radiation is called an albedo, which varies from 10% over oceans to 85% over snow. So obviously over seas and oceans it gets absorbed, whereas over snow and ice it gets reflected. This diagram shows how on the surface we get our solar energy. Only 24% of solar radiation reaches the Earth's surface, so all the radiation that comes from the sun we only get 24. 21% of that 24% reaches the surface as diffuse radiation. So the way it gets diffused is coming in contact with clouds or dust in the atmosphere. So the amount of actual radiation we get from the sun is quite small, and that's another reason why the atmosphere is so important and why it has such an important function to life on Earth. All the atmospheric processes lead to a global heat budget. A budget is a set amount, and in this case of heat. Obviously the Earth's temperature does remain constant overall, therefore there must be some sort of balance of incoming and outgoing on land radiation. These are the basic patterns. Basically we get net gains in radiation everywhere except at the poles. Why do you think this is? Well, because the poles are cold, they're furthest away from the equator, and because they're normally covered in ice, they do reflect radiation waves. Overall, we do have a net loss throughout the atmosphere, and it's all to do with that reflection and the way that the ozone's made up. It allows sunlight in as well as out. However, we increase carbon dioxide levels in the atmosphere, it holds in that light. That's why that's so important, the ozone layer, and we make sure that that's maintained. Otherwise, if we increase the composition in the atmosphere, we do have what's called the greenhouse effect, where that sunlight that's been reflected off the surface gets held in. There's a net surplus at the tropics. Obviously, between the tropics, we're going to get more and more heat. I remember going back to the previous slide, why does the equator get so much heat? Because it's in the center of the Earth and is closest to the sun.